For decades, every move on Mars has been carefully choreographed from Earth. Engineers study images, calculate risks, plot routes, send commands, and then wait, sometimes for hours, to see what happens. But in December 2025, something changed. For the first time ever on another planet, artificial intelligence took over the route planning for NASA's Perseverance rover and decided for itself where to drive. Perseverance rolled about 700 feet across the rim of Jezero Crater on December 8th, and then added another 800 feet a few days later. That might not sound dramatic, but this wasn't just another routine drive. Instead of relying on human planners at NASA's Jet Propulsion Laboratory to map out fixed waypoints roughly 330 feet apart, the rover followed a plan generated by AI. Normally, teams at JPL analyze high-resolution orbital images, terrain maps, and rover health data in painstaking detail. They craft a step-by-step path and transmit those instructions roughly 140 million miles to Mars. Because communication isn't instant, they have to wait for signals to travel back and forth before issuing the next set of commands. It's safe and reliable, but it limits how much ground the rover can cover in a single Martian day and demands hours of work from engineers. This time, engineers introduced generative AI into the process, using vision language models from Anthropic's Claude family. The AI studied the same data human experts rely on, including sharp imagery from the Mars Reconnaissance Orbiter's HiRISE camera and detailed slope information from digital elevation models. From that, it identified terrain features like bedrock exposures, rocky outcrops, clusters of boulders, and shifting sand ripples that could trap the rover. Instead of plotting a handful of rigid checkpoints, the AI generated a continuous driving plan with smart waypoints built in. But safety remained the top priority. Before anything was sent to Mars, the entire route was tested using a digital twin of Perseverance at JPL, a virtual replica designed to mirror the rover's real-world behavior. The simulation ran through nearly 500,000 telemetry points to confirm the plan matched the rover's flight software and wouldn't cause trouble. Only after passing those checks were the instructions transmitted through NASA's Deep Space Network. On Sol 1707, Perseverance completed its first AI-planned drive, traveling 689 feet. 2 sols later, on Sol 1709, it went even farther, 807 feet over about 2.5 hours. Navigation cameras recorded the journey, and later reviews showed how closely the rover's actual path matched the AI's predicted route. Vandi Verma, a roboticist at NASA's Jet Propulsion Laboratory, explained that the real breakthrough is how generative AI can simplify off-world driving. It clearly interprets the terrain, understands the rover's position, and selects the safest possible path forward. If this approach continues to prove itself, future missions could move faster and operate more independently, spending less time waiting for instructions from Earth. And that could open the door to exploring more challenging terrain on Mars, and maybe one day, even farther into the solar system.